Hi guys, welcome to my YouTube channel Suri Studio. Welcome to Linux season. Today we will discuss most important topics in Linux, that is LVM. LVM means logical volume management. Okay, why LVM? It's a logical value management which includes allocating disk, strafing, mirroring and resizing the logical volumes. Okay, first of all, why this LVM? For example, we have a disk size of 2 GB. We are start adding the data into that single file. Eventually the 2 GB is full. In this case you need another disk to larger than 2 GB. For example, uh, we'll add the 8 GB of data later, or else that 8 GB also full. Okay, how far you will be migrating file from one disk to another disk and so on. And also for you need to add the disk into the server, we need downtime as well. So not possible to every time to do the downtime and add into the disk to the server. To avoid these circumstances and also, we can implement the LVM to store data into the volumes. Okay, like there is a components in LVM. uh, we use the LVM, we can increase the disk, as well as if you want to increase the disk, we can increase it. If you don't want that much of data and all, we can reduce it as well. Okay, LVM, it is a mechanism to virtualize the disks. Then it can create a virtual disk partitions out of one or more physical hard drives, following you to grow or shrink, move those partitions from one drive to another drive as your needs. As per the change, we can mount these partitions to another file systems as well. It also allows you to create a larger partitions that you can achieve with a single drive. With single drive, we can do all these things with LVM. Main advantages are with LVMs is increase the abstraction, flexibility, and control. Okay, there is some components in Linux: physical volume group, and logical volume. Physical volumes, physical extents, volume groups, logical volumes. What are these? What is physical volumes, and what is physical extents, volume groups, and logical volumes? Okay, and logical extent as well. Components: physical value means it is a standard partition that you add into the LVM. Normally a physical value is a standard primary or logical partitions with the hexa code 80. If you remember last time while doing the partition, that code is 8 is there for Linux, but if you want to do LVM, the hexa code need to change to 80. Okay, and physical extent, what it is: a chunk of the disk space. Every PV divided into number of equal sized extents parts. Volume group, it is the most important. Composed group, PVs and LVs, it is organized group for LVMs as well. Logical value, it's a composed group of logical extents. You can format and mount any file system on an LV. The size of these LVs can easily increased or decreased as per the client requirements and as per the our needs, as per the server data and all. Logical extent, it's also chunk disk space like as a physical extent, but in every LE is mapped to the specific PE. It is linked to the physical extent. Creation and syntaxes. PV create means first we can create a one partition in /dev/sda or sdb. Then we can map the code to 80. Then we will create a PV create to that partition. Okay, this is the syntax. PV create, that partition name means /dev/sdb1 sdb2, like that. Okay, we can see later after this part we can go with the practical sessions. Next, vg create. Vg create, as per the pv create we can create the vg create. See here, vg create, that vg name whatever we, for our understanding or for our need, we can create the one vg name with partition name. We can configure partition name with vg name. Then lv create, to create a new logical values. It's interlinked with vg. Okay, lv create hyphen l, capital L, size whatever we need that size, lv name whatever that need or requirements, vg name. This vg name is same as this whatever we created before, right? That vg name. Then vgextend means add a new physical disk into the volume group. For example, if you need to increase the disk size but you don't have any space in that lv, in lvs, first we need to extend the vg, then we will add the space into the lvm. For this vg extend, that vg name, partition name, first we can extend the vg name whatever the existing vg name. First we need to extend that vg name which is mapped to the partition. Okay, which partition need to extend, then we can extend the lv extend a logical value. See here, lv extend hyphen l, that addition size what need to, for example if you need to 2 gb or 4 gb or 8 gb, plus that gb you need, or else mbs if you need, you can put the m. Then that whatever that partition mount point slash dev slash vg name slash lv name. Okay, these all are the commands to displace the all physical values. pvs is the command for vgs. Vgs is displays the all volume groups in the systems, not only the particular partitions. It displays the all vgs into the system. Then lvs displays all logical values in the systems. Then pv display detailed information on physical values, means pv is means configure to which vg, which lv, like that. Same as vg display also, it gives the detailed information on vg groups. Then lv display as well. These all are the lvm part what we need to do and all. Okay, first is a logical, first physical value we can create into that physical partition, then we can create the volume groups, then we can create it to the logical values. For that logical values we can mount the whatever that file systems, we can mount it, or we can uh, map to that file system to the lvms. Okay, these all are the components: physical values, physical extent, volume groups, logical value, and logical extents. We have so many commands is there for that lvm commands. lv resize, we have lv reduce. pv moves means moves data from one physical value to another physical values. If you don't need the physical values or vg volume groups and all, we can remove it using the pv remove, vg remove, lv removes commands. Let's start the mission. Before starting this mission, you need to update some settings in missions. What is, go to settings. Here in storage, you need to map the ISO image to this one, and you can add additional hard disk to the storage. And in networks, you can add the second one as NAT and also host only adapter. Okay, these two settings, make sure these settings need to update before going to do this practice and all. One is in storage, you need to map the ISO image to this controller ID. For controller data, you need to add the one hard disk. How to add a hard disk means here click on this add hard disk or else add hard disk. If you give means for this you need to power off the machine. Okay, if it is running the machine, it won't take to add the disks and all. Okay, first power up the machine, then you can add the hard disks and all for this. Then you can start the machine. It's automatically displayed into the our machine. These all are the settings need to update before starting these LVMs and all. Yeah, mission is started. Yeah, we will connect with putty. One, two, three, four. Yeah, it's connected. To see the disks in server, fdisk -l. See, its new disk is created here. This /dev/sdb is the whatever we added the disk in SATA, that is the this /dev/sdb disk. Here, this is the default disk for OS /dev/sda, means that all configuration files, whatever the files, bootable files and all there in /dev/sda. Don't do partitions under SDA and all. You need to add the hard disk into in storage, then you can do partitions and LVMs on external disk. Okay, let's enter into the disk. fdisk/dev/sdb. So if you give m, it displays some actions what you need to do and all. We can create one partition here first. N for new partition. So add a new partition. Primary. Default I am creating SDB1. Defaults as I am taking plus 2G I'm creating with 2 GB. Yeah, partition 1 is, if you give the P, see, it's created with ID is 83. Okay, if you want to do this for LVM and all, we need to change this ID to 80, hexa code 80. For that, give the T here. Partition number hexa code 1. It's asking for which partition you need to add. 8E. I'm giving, I know that hexa code of LVM, that's why I'm giving this. See, change the partition. If you give P, see, it's Linux LVM. Before it's 83 is the just Linux LVM for 80 for the Linux LVM. If you want to know that and all, give L. See, these all are the codes. 0 for empty, 1 for fat and all. Here 80 for Linux LVM, 83 for Linux, 82 for Linux swap. Whatever you want, you can update these codes to the partition whatever we created. I'm giving M for help. See, I am giving w, write table into disk and exit. Okay, I am giving w. See, calling to read partition, syncing disks. Fdisk. See, it's created. /dev/sdb1 with 2 GB. It's in kbs and code is 80 hexa code. We can call it as a hexa code for Linux LVM. 80 is the hexa code for Linux 83. See here in for SDA there is a two. One is for Linux, one is for Linux LVM. Okay. Then we can create the PV for the partition. Newly created partition. PV create /dev/sdb1 physical volume /dev/sdb is successfully created. If you want to display this one, just give pvs. See here /dev/sdb lvm2 2 GB data, free is 2 GB. If you want to more information about this PV, just give PV display. It gives the all data. /dev/sdb 2 GB data is there. Allocatable, nothing is there. PE size no. All is free. Allocated. PV UUID. In partition, we got the UUID, right? Whatever we did the partition, this is the UUID. See, for this PE size is 4 MB is there. Total this physical extends, it's means it's divided equal parts into 1791 parts. Allocated PE 1791 part means these equal parts it's created automatically. Allocated, yes, one is allocated but it's full. It's saying but it's full. Okay. Vgname. This Vgname is configured to CentOS, but here Vgname is it's not showing. Means we didn't create the Vgname yet. We will create it. Creating the VG. For VG create. Name of the VG create. Can give VG test. We can give for /partition name /dev/sdb1. See, volume group successfully created. VGS, I am giving VGS. It shows two VGs is there. One is CentOS, one is VG test. If you want VG display, see VG name VG test, system ID it's not created yet. Access read and write. VG status resizable means we can extend or we can reduce it. PE size 4 MB is there. PE allocated PE free PE. Now if you give the PV display, see here VG name is allocated for this PV. Now we can create the LV part. Means we already this VG is ready for us. Then we can create the logical value. That syntax is for logical value lv create -l, that size -n, lv name, vg name. Okay, see here lv create capital L. For this lv I'll give 300 MB. Now 300 m -n. I can give lv test to which one, vg. Vgtest. Okay, I'm creating now with 300 MB this lv. See, logical value lv test is created. Lvs, it displays the logical value lv test under Vgtest. Under which volume groups? Vgtest. How much memory we created? 300 MB we created it. Lv display lv test means we need the only lv test. Display, yeah, see, yeah, lv path where it is /dev/vgtest lv test. Okay, with this we can mount the partition. lvname lv test, vgname vgtest, uuid for this, access, read and write, lv size 300 MB, current LEs means it's divided into 75 equal parts in LVs, allocation and all, block devices. These all are the details about the logical volumes. Sorry, LV display VG test. See, logical value. If you want to see the particular VG, directly LV display that VG name, whatever that map to which VG name VG test, it shows that particular LV names. Okay, now adding the file system into LV and mounting into this LV. Okay, now we can add the mkfs.ext4, we can add it. Which file system? This is the path /dev/vgtest/lv test. Okay, ext4 we are mapping. See, writing super blocks on this, done. No issues with under. This is done. Now mounting, we can create the one directory here, mkdir lvm, we can create it. Yeah, lvm, we can one directory, we can mount to this lvm, mount this one, that dev/dev/vgname lvname, then /lvm. Okay, to this directory we are mounting this lvm. Mount slash does not exist. Yeah, see, q the df-h, see, /dev/vg lv test is mounted on /root/lvm. Okay, this mounted on this one. Okay, got it. Then we need to entry into fs tab, vi/etc/fs tab. To get permanent, we will add the entry into the fs tab, same like insert mode, /dev/vgtest/lvtest, ext4 defaults 0 0. Okay, okay, exit from insert mode, then wq. Yeah, this mount point is permanent in fs tab. Okay, now extending the volume groups means how we can extend. To extend the volume group, we need to create a new partition using fdisk, and also map that hexacode to 80 in the partition table. Then we can create the PV. Why we need this Vgextend means in Vg there is no space at all. That's why we can create the Vg. If you have a enough space to increase the LV, directly we can increase it. Okay, if you want to increase this, for example, we given the 300 MB now, right? If you want to increase it, directly we can lvextend command, we can give it lvextend -l plus another 400 M I need it to /dev, sorry, /dev/vgtest /lvtest. Okay, after that we need to resize to a file system using the resize to command. See, logical volume vgtest lvtest successfully resized. Then we can use the resize to fs command. Resize to fs means that fs needs to resize it to which one, /dev/ this one, /dev/vgtest lvtest. See, file system online resizing required old 6, now it's a 7166 blocks long. Okay, now it's extended. See, we extend the 400 MB to this file system, it's extended. Before it's a 283 MB, now it's a 671 MB. Okay, this is the how we can extend the logical value, means increasing the size of logical value. If we have a 2 GB is there, that's why we increase it. If you don't have the space in that partition, that scenario is different. Means first we need to extend the VG, then we can extend the logical values. For Vgextend, we can create the one more PV, means we can create the /dev/hdb2, then we can map to PV create, add the partition into this VG, then we can extend it. Means how much we need it. For example, if we need some data 500 MB like that, whatever, while creating the partition, you can add it, then you can extend it. Okay, Vgextend. For the same Vgextend, we can do it. Means for example, now VG test is there, right? For that, we can map to /dev/hdb, then we can extend the LV. That is the process. But if you reduce this LV, the scenario is different. For reducing the LV, first we need to unmount this, the partition, then e2fsck command /dev/ that one, this update the file system whatever we need it, then lvreduce command we can use it, then we can use the mount-a command to remount the same file system into it. Let's see, first unmount it, unmount this one, sorry, umount df-h. So no more file systems under this LV. Now we can use the e2fsck command to organize the data. e2fsck -f, which one, /dev/vgtest/lvtest. Okay, checking in notes in the blocks 0% configuration, it's okay, pause. all is fast. Then we need to resize it, means we need to reduce the 200 MB like that. Resize to fs /dev /vgtest lvtest. To which MB need to reduce it. For example, 200 MB. I need to means decreasing the MB to 200 MB in that file system. The file system blocks long. Okay. Now I can use the lvreduce command to reduce the file system. lvreduce -l minus 200 m to /dev for /dev vgtest vgtest lvtest. Before this size is 600 something, now we are reducing to 200 means reduce it to 200 MB. Now it's something. This may destroy your data. Warning reducing. See, this file system is warns you reducing active logical volume to 500 MB. This may destroy your data. Means if any data is exceeded with that 500 MB and all, the data will destroy and all. It's warning you. Okay, I'll give yes. Yeah, logical volume successfully resized it. Give the mount-a to mount automatically whatever the data in fs tab. It's automatically mounted to server. Now df-h. See, 186 MB there. See, 500 MB means minus 200 means it's just taking the 200 MB only, not reducing. How much need it? 200 MB we need it, just give the 200. If you need the 500 MB, just give 500 MB. It will reduce from 800 something. Okay, this is the how LV extender, how to reduce the LV. Okay, if you want to remove the data, means LV PV or LV VG, just give PV remove, VG remove, LV remove, like that. If you want to remove that one, first we need to unmount the file system, then you can remove it. This is about the LVM concepts, and it is one of the most important topics in Linux. Please subscribe to my YouTube channel for more exciting videos about Linux. In future we will update the some DevOps classes as well. Thank you guys.